The theory that there is life on Mars has captivated scientists, science fiction enthusiasts, and the general public for centuries. Mars, often referred to as the Red Planet, has long been considered one of the most likely places in our solar system to harbor life outside Earth due to its proximity and some Earth-like features. This theory encompasses various lines of inquiry, including historical observations, modern scientific missions, and current research. Historical background. Giovanni Schiaparelli, in 1877, the Italian astronomer observed what he called canali on Mars, which was mistranslated as canals, implying artificial structures. This sparked speculation about intelligent life on Mars. Percival Lowell, an American astronomer who popularized the idea of Martian canals and an advanced civilization. His detailed maps and writings in the late 19th and early 20th centuries fueled public imagination. Scientific exploration. Early space missions. Mariner missions. In the 1960s and early 1970s, NASA's Mariner missions provided the first close-up images of Mars, revealing a barren landscape without the expected canals. Viking landers. 1976. These NASA missions were the first to land on Mars and conduct experiments to detect microbial life. The results were inconclusive and have been debated ever since. Modern discoveries. Mars rovers, Spirit, Opportunity, Curiosity, Perseverance. These rovers have provided valuable data on Martian geology and climate, uncovering evidence of past water activity, essential for life as we know it. Mars Reconnaissance Orbiter. This orbiter has detected hydrated minerals and seasonal streaks that suggest the presence of liquid water flows. Key evidence and arguments. Water on Mars. Past water, geological features like river valleys, lake beds, and minerals that form in the presence of water suggest that Mars once had a much wetter environment. Present water, seasonal dark streaks called recurring slope lineae, RSL, indicate the potential presence of liquid water, likely salty brines, on the Martian surface today. Methane emissions. Methane plumes. Observations from the European Space Agency's Mars Express and NASA's Curiosity rover have detected fluctuating levels of methane in the Martian atmosphere. Methane can be produced by both biological and geological processes, so its presence is intriguing. Meteorite evidence. ALH 84001, this Martian meteorite, found in Antarctica, contains structures and chemical compounds that some scientists argue could be fossilized microbial life. However, this interpretation is controversial and not widely accepted. Theoretical models and hypotheses. Extremophiles. Adaptation to harsh conditions. Life on Mars, if it exists, might resemble Earth's extremophiles, organisms that thrive in extreme environments. Mars' surface is harsh, with radiation, low temperatures, and a thin atmosphere, but subsurface niches could offer more hospitable conditions. Subsurface life. Underground habitats. The possibility of liquid water beneath the surface opens the potential for life in Martian aquifers, protected from the harsh surface conditions. Current and future missions. Perseverance rover. Mission goals. Launched in 2020, Perseverance is equipped with sophisticated instruments to search for signs of past life and collect samples for potential return to Earth. Sample collection. The rover is gathering Martian rock and soil samples that future missions aim to return to Earth for detailed analysis. ExoMars. ESA's mission. The European Space Agency's ExoMars program aims to drill into the Martian surface to search for biosignatures and study the planet's geochemistry. Future proposals. Mars sample return. Joint missions by NASA and ESA are planned to bring back Martian samples to Earth, potentially providing definitive evidence of past or present life. Human missions. Plans by NASA, SpaceX, and other space agencies and companies to send humans to Mars could dramatically increase our ability to search for life and study the planet's environment firsthand. Challenges and controversies. Contamination. Forward contamination. Concerns about contaminating Mars with Earth microbes, which could compromise the search for indigenous Martian life. Backward contamination. Potential risks of bringing Martian samples back to Earth and the need for stringent containment and testing protocols. Interpretation of data. Ambiguous evidence. Many findings, such as methane emissions and potential biosignatures in meteorites, can be explained by both biological and non-biological processes, leading to ongoing debates within the scientific community. Technological limitations. Current capabilities. Despite advances, our current technology limits the depth and scope of exploration. Subsurface exploration, in particular, requires more advanced drills and sensors. The theory that there is life on Mars remains one of the most exciting and contentious topics in planetary science. While there is no definitive evidence yet, the tantalizing clues gathered over decades of exploration continue to fuel the search. The discovery of even microbial life on Mars would have profound implications for our understanding of life's potential to exist elsewhere in the universe. As technology advances and new missions are launched, the coming decades may finally answer the age-old question of whether we are alone in the cosmos or if life has also found a way to survive on our neighboring planet, Mars.